Hello and welcome again to Organic Chemistry. And today we're looking at how to name organic compounds. So we're looking at what we call nomenclature. So we're going to follow the standardized system, IUPAC names. Now to start with, we'll look at a functional group and decide which functional groups do these molecules belong to. So if you look at this structure here, it only has carbon and hydrogen, and because of that, those are called alkanes. They have single bonds, no double bond or triple bond. These systems here have at least one double bond, and because of that, they're called alkenes. E-N-E, alkenes. Then these two have triple bond, so those ones are called alkynes. This here has an OH group, and therefore it's an alcohol. These two have halogens, so fluorine and bromine, and because of that, they're called alkyl halides. This is also an alkyl halide because it has iodine. It's a cyclic alkyl halide. This has an NH2, and therefore they're called amines. And this is a more complicated functional group. It has an alcohol and it has an alkyl halide. This has a straight chain alkane, a cyclic side group, alkane, and a benzene ring, a phenyl ring, so an aromatic compound. So this also has a mixture of functional groups. Now we'll go ahead and name each of these molecules. And I would like to take your time to ask you that if you enjoy this presentation, or if you like it, please like the video, share, and also subscribe. So for alkanes, we count the number of carbons, and then the parent name ends with A and E. So in this case, we have only one carbon, so that will be methane. This has 1 and 2 carbons, and therefore that's going to be ethane. This has 1, 2, 3, and 4 carbons, and therefore that will be butane. You see, they all end with A and E. This is a cyclic system, has 1, 2, 3, 4, and 5 carbons, and therefore you start with cyclo, and because it has 5 carbons, pentane. So cyclopentane. Now let's look at the other alkane. This has 1, 2, 3, 4, 5, 6, and 7, and therefore the name will be heptane. Next, we look at the double bond system, and those ones are alkenes. So this has 1, 2, 3, 4, 5, 6, 7. If we count starting from the left, we see that the double bond starts from carbon number 2, and it has 7 carbons. We saw that 7 carbon is heptane, so now it's going to be, we show the position of the alkene of the double bond, so 2 heptene, or you could say hept 2 in, where the 2 shows the position of the double bond. We can apply the same here. 1, 2, 3, 4, 5, 6, 7. We want to have the lowest number for the double bond, the lowest position. So if we count from the left, it starts from carbon number 3. But if we start from the right, it will start from carbon number 4. So it's better to start from the left. And because of that, it has 7 carbons, it will be 3 heptene. Or you'll say hept 3 in. And then this has 1, 2, 3, 4, 5, 6, and 7. And the double bond is on position number 1, so that's 1 heptene. But because it's at position number 1, we really don't have to show that, so we can just call it straight heptene. And then this is a cyclic alkene, has 5 carbons. We saw that the name for cyclic system without a double bond is cyclopentane. Now this will be cyclopentene. And we don't have to show the position of the double bond because we start from carbon number 1. This system here is an alcohol. It has an OH, and let's see how many carbons it has. 1, 2, 3, 4, 5, and 6. And because it has 6, that's hex. So it will be hexanol. Hexanol. You could also name it as an alkane, and in that case, it will be hydroxyhexanol. This triple bond has carbon number 1, 2, 3, 4, 5, 6, and 7. And the triple bond is on the first carbon, so that will be heptine. Remember YNE for the triple bond. In this other case, if we label it from the left, it will be 1, 2, 3, 4, 5, and 6, 7. If we start from the right, it will be 1, 2, 3, and 4. So it's better to start from the left. And we see that the triple bond is on carbon number 3. So that will be 3-heptine. Or you could say hept 3-YNE. Ine. Next, we go to alkyl halide. So this has 5 carbons and has an iodine at that position. So that will be position number 1 here. So it will be iodocyclopentane because it has 5 carbons. This has 1, 2, 3, 4, 5, and 6. So that will be fluorohexane. If you make the parent name an alkane. But you could also make the parent name to be alkyl halide. So in that case, it will be hexyl fluoride. Here we have 1, 2, 3, 4, 5, and 6. So that will be bromohexane. Next, we look at the amine. So let's label the carbons 1, 2, 3, 4, 5, 6, and 7. We see that the amino group is on carbon number 3. So that becomes 3-aminoheptane. This structure here has a cyclic system, and then it has 2 side groups. So that group and that group has CH3 and CH3. So those two becomes methyl. So methyl group, but there are 2 of them. So it's dimethyl. And then we have iodo for the iodine. And we have the OH, so that's hydroxy. And we know that the parent name is cyclopentane. But now we need to show the positions or the locations of these side groups. If we start numbering from here, it will be 1, 2, 3, 4, 5. But you'll see that at position 3, we have 2 groups. So it will be 3, 3. And that's not preferred. We want to have the lowest number possible. So if we start from here, it will be 1, 1. So that's better than 3, 3. And then 2, 3, 4, and 5. So we know that that's position number 1. Next, we will need to arrange the side groups in such a way that they are alphabetical. So we see that H comes before I, which comes before M. So in that case, we're going to start with the hydroxy, and it's at position number 1. So 1 hydroxy. Next, iodo. So dash 2, it's at position number 2, iodo, dash. Next, we have 2 methyl groups, that and that. So at position number 1 and position number 3, so we say 1, 3, dimethyl. So we finish all the side groups, and then we just add the parent name, which is a cyclic system, so cyclopentane. And that will be the name of that structure. The last structure has several cyclic groups. So we'll see that the best way to label the straight chain, which is the longest, and that becomes the parent chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it has 11, and anytime you have a long chain like that, write a parent name for that. So that's unidecane for 11 carbons. And then we have this aromatic system from benzene ring, and when it's a side group, it becomes phenyl. And then we have this 3-membered ring, so it's 1, 2, 3 with carbon, so that's cyclopropyl group. And now we just need to arrange them alphabetically. We see that pH comes before PR, propyl. So we start with the phenyl, which is at position number 7. So it will be 7 phenyl dash. Then we come to the cyclopropyl on carbon number 3, cyclopropyl. And then we finish all the side groups. Now we add the parent name, which is unidecane. Thank you very much. If you enjoyed this presentation, please like the video and also subscribe here. Bye. See you next time.